Hi everyone, welcome to today's class. This is my lecture number 7 and the topic is reactions of carbene. So in the previous video I have talked about carbene. So you all know now the carbene is. If you have not watched this video, please watch it first and then come to this video. That will be helpful for you. Okay. So this chapter or this lecture will be from obviously reaction is a part of a reaction intermediate obviously, and also name reaction, because in organic chemistry many name reactions are in the syllabus of CSIR NET, and we have to cover the most of it to solve the questions from organic chemistry. So here I thought that in the reactions of carbene, I should incorporate some of the I should introduce you some of the name reactions to you, so that it will be better to understand. Okay, so hope you will enjoy this session, and please make sure to have you have a plain pen and paper with you so that you can practice with me. So let's start with today's topic. Okay. So this is the I am starting the reactions of carbene. Okay. So reaction with alkene. In the previous lecture itself, I have talked about this in a short way, I will say, but yes, you know this, right? So I have explained all the things, but as this series actually is meaning that the reactions of carbene I will talk about. So I have to I had to incorporate this also. So just a quick recap, so that that is the reason that I kept these slides, these two slides actually. So the reaction with triplet carbene. So in the case of triplet carbene, what it was actually, it is not a stereo specific kind of reaction. Okay. So in the case of triplet carbene, what is happening is that when this kind of reactions are actually going on, we know, right? You know, if you watch the previous lecture, you should know that when we add actually carbene with the let's say here we are talking about triplet. For singlet carbene, let's say, so for the singlet carbene or any carbene, the reaction with alkene, it will give a cyclopropane ring. Okay. So for the singlet carbene, it is stereospecific, means cis will give cis product with the cyclopropane, and trans will give trans product. Okay, trans give trans. It was the case, but so it was stereospecific for the case of singlet carbene. But for the case of triplet carbene, it is more important because of the reaction course, the mechanism. Okay, so what is happening here is these two actually this carbene has as it is triplet, two, let's say, up spin, two up spin electron are present. Okay, so we know that for bond formation, one up and one down spin will form the bond. So if we break this double bond as like this one electron will go to here and other one will go to here. Okay, for the to understand the mechanism of it. Okay, so here it let's say here it is this down spin and here it is up spin, like that. Okay, so this down spin and here up spin, that will form a bond, but here one up spin, this one will be left, and here up spin, one up spin will be left. Okay, but these two doesn't form a bond because both are up spin. One has to be the down spin, so that it can actually couple. Okay, so for that it is called actually triplet intermediate, as the spin multiplicity is here the 3, so that's why triplet intermediate. So here spin inversion is going on, which involves the one up spin will go to the down spin, and now they can form a bond. Okay, that is the case. But one important thing, and one actually in the reaction course, when the spin inversion is going on, that process is slow process. So when the spin inversion is going on, there is the possibility of the rotation of this single bond. Okay, so here it is the twist. Okay, so due to rotation, now we have started with cis alkene. You can see. So there are now two possibilities of this triplet intermediate. First, okay, let's say this is the one possibility. This is the possibility number one. This is one. This is two. Okay, where these two are cis as the reactant molecule, but if the rotation happens, it will be trans. So both are possible, and both will undergo spin inversion. And then in the singlet intermediate also, 1 dash plus 2 dash after the spin inversion, let's say 1 dash and 2 dash will form. So it will be the mixture of 1 dash and 2 dash. Okay, here stereochemistry is not mentioned. So these two will be there. And then when it form bond, the two possible product will form. One will be cis, okay, one will be cis, which should be the product if the reaction is stereospecific, but here it is not the case. So here both cis and trans will form. Okay, so these two will form in a ratio, in a certain amount of ratio. So that's why this reaction is stereoselective. Okay, so now the insertion of CH bonds. So in the reactions of carbene, one important reaction is this also, where when nothing is given in the reaction condition after the carbene formation, if in the reaction condition nothing is given to react with the carbene, as we know that carbene is not stable, it is intermediate, so it should react with someone. Okay, but if in the reaction medium nothing is present which can react, then that time what will happen? It will intramolecularly it will react. How? Insertion into CH bonds. What will happen then? This H will move towards this carbene carbon, and here will one double bond will form. Okay. So here in this case, there is an example you can see. So here metal is present. So we know that when this kind of diazo compounds are present, H nu or heat or any metal will, in presence of H nu, heat or metal, it will lead to the formation of carbene. Okay. And after the carbene formation, as nothing is given in the reaction medium, this will undergo intramolecular reaction. CH bond insertion into CH bond will happen, and here 1 2 3 4 5, so 5-member ring is favorable, so that's why from this carbon actually the hydrogen will be shifted. So for your understanding purpose, so to know it clearly, so I will draw a simpler form so that you can understand how this H is migrating and how this double bond actually coming. Okay, so H is there. Let's say this H actually, this H, okay, and here carbene is there. So in radical fashion, if this bond cleaves, that time what will happen? This one H is there. Here carbene present. Here one dot, one H present, and one H dot is here. Now, if this and this will form bond, and here one radical will be there and it will join with this hydrogen. Understood? Then this kind of intermediate will form. This kind of product will form. How? This one. Okay. This hydrogen is from this carbon. Is coming from this carbon. This one. 1, 2. So this is coming from 1. Okay. Understood? So now I am starting the new part of today's session. So I am starting with the name of the reaction, as both ways it will be helpful. It will be helpful. We will study the name reactions as well as the how carbenes are actually reacted. So that is the thing here. So Simon-Smith reactions or Simon-Smith reaction, anything you can actually pronounce here. So what is this? So the naming is not important here. You have to, for any name reaction. Okay, I will tell you, for any name reaction, what you should remember. So you have to remember that. So in the reaction, in the question, there is very little questions are there, or very few questions are there, that where name reactions are actually named by the name. Actually, they are asking question, but in in most of the cases, what is happening is that only reactants conditions are given. You have to draw the product, or the vice versa. Okay, so you have to have the idea about the, so naming is not important there. Only the reactant which is needed for this kind of reaction, and the reaction conditions and product, obviously. Okay, because in the exam hall, you don't have much time to draw the mechanism and all. So you have to identify the reactant, and the conditions are given. Okay, so this is given and this is the condition, so that will be the product. Okay, sometimes confusions can be there, but you have to have the idea that this is the reactant and this is the condition, so reaction can be this one. Okay, so that's how I am actually teaching you this kind of reactions. Okay, so this is okay. This is also a addition to alkene, which we have read about the cyclopropane ring formation. But here, why this is a name reaction, that SS reaction, Simon-Smith reaction? How to know that it is a Simon-Smith reaction? How? So first, one alkene should be there, because it is a addition to alkene, addition of carbene to alkene. Okay, and the condition, or the other reactant, reagent, CH2I2 and Zn I or Zn copper. Okay, so that will be your reaction condition. Okay, so if alkene is present and CH2I2 and Zn or copper, okay, any metal is present, so you have to, many times Zn will be written. You have to understood that, okay, this is Simon-Smith reaction. So in the case of Simon-Smith reaction, what is happening is that, so this kind of cyclopropane ring is formed. Okay, so this is the mechanism. So why metal is important here? Metal actually is making the chelation. So here not directly the carbene is attacking. So carbene is here much stable because of the Zn, and because of the Zn, actually the carbene forms, which is formed here, is the singlet carbene. Singlet carbene. Okay, singlet carbene here important. Because of the presence of a metal, this singlet carbene is stable. Okay, because it has a vacant orbital. For singlet carbene, we know na, one lone pair is present in the sp2 orbital and one p orbital is vacant, so metal can back donate. Okay, so here singlet carbene is formed and not directly attacked, it is attacked through the zinc. Yes, zinc carbenoid. This is the thing here. CH2I2, you can see CH2I2 is there, zinc copper, and ZnI, this kind of zinc carbenoid is formed, which is attacking the uh, alkene. Okay, and cyclopropane is formed. So carbene transfer from the metal to the alkene without any free carbene being released. Understood? Next. So the mechanism. Okay. So how it is actually happening? It is simple. So it is, we know that carbene has carbene, the nature of carbene. Remember this, right? So it is a 6 electron species, neutral, it doesn't have any charge, but as it has 6 electron, it want to have 8 electron in its valence shell orbiter. So that's why it has a tendency to for the electron acceptance. So it is electrophilic, tendency to accept electrons, electrophilic nature is present in the carbon. So, and here double bond has pi electrons. It has a high concentration of pi electrons. So it can attack in the electrophilic center, right? And Z and I will be goes to here. So now what is forming is that this kind of intermediate will form, which leads to the formation of this kind of, right? So now reaction is stereospecific. Why? Before that, what is stereospecific? When the stereo chemistry of the reactant is maintained in the product, that is called stereospecific, or the reaction condition which is given is specific for the formation of a specific type of uh, a product of specific stereochemistry, right? So this is very tough words, right? Simply, cis will give cis product. Trans, which groups of trans in reactant, that will be trans in product also, right? This is stereo specific. But how can we explain? I previously told you in this reaction, singlet carbene will form, singlet carbene. And also in the first slide, I said you, and in the previous lecture, obviously, if you watch this video, you will know that for the case of singlet, the reaction is stereospecific. So that's why it is written that the Simon-Smith reaction. Simon-Smith reaction is stereospecific in nature. Okay, but there is a but. Stereoselectivity comes due to adjacent polar group. What does it mean? So here comes the novelty or any difference, because we know that carbene when reacts, the cyclopropane ring will form. But then how it is a named reaction? Specific type of reagent we are using, and yield should be better. Okay. So here another important thing we got, that stereoselective product will be formed also. This is not usual, right? Because singlet gives you the stereospecific, but here stereoselective product will also form when adjacent polar group is present. So take an example like this. Okay. So when polar group like OH, this can be OMe. Okay. So this kind of groups are when present, which has lone pair in it and can chelate with the metal. The reason is actually chelation. Okay, so that we will understand you and we will read. But before that, what is happening is there when adjacent allylic alcohol it is. So for the case of allylic alcohol, when we are zinc, copper, and CH2I2 is given, it will give cyclopropane obviously, but the stereochemistry is upside. Okay, so up bond will form. Understood? Because this stereochemistry is mentioned and it has a polar group, it will be the cyclopropane ring will form from that side only, from the side of the polar group. Now why? Cyclopropane ring will form from the same side of the alcohol group. Why? Question. So in every step, what you are reading and some reaction, some mechanism, everywhere, you should have the questions in your mind. Having the questions is the great thing to understand a topic. You should have the questions in your mind. Okay, then you will know that you are interested about to know many things about this. Okay, so here this kind of chelation will happen when here any polar group will present. Through oxygen and I, it will form this kind of overlap. It will chelation. So due to chelation, this kind of transition states are more stable than the other one. Okay, so two products will be formed. One will be in higher amount. This will be major. This will be major. Other one will be minor. Okay, and most important thing is that due to this kind of chelation, the reaction will be faster also. Let's say here, this is compared with the same thing which doesn't have this polar group. Let's say any R group present or anything is not present. In this case, the reaction will be rate will be slower than this one. This has the faster rate. That is also important. Okay. So please remember this, that stereoselective reaction it will then undergo, and the stereochemistry will depend on the polar group. So the cyclopropane ring will form at the same phase, from the same phase where the polar group actually lies. One important thing, and second thing is due to this kind of chelation, reaction will be faster. Okay. Now examples. Okay. This is very interesting example if you know. Let's say in this reactant, two polar groups are present and two double bonds are also present. So if we think that for the case of only this, let's say when this is given Et2Zn and CH2I2, CH2Cl2, this is also Simmons-Smith reaction. Okay, one condition is there. So whenever you see Zn and CH2I2, the Simmons-Smith reaction will happen. Okay. So here for the case of, let's say we are thinking about this double bond. It is adjacent to this one which is down. This polar group is down, but it has another adjacent little bit far away, but it is also adjacent, right? So it is from up. It is lying upside. So how we can know about the cyclopropane ring for stereochemistry? So here comes the important thing is that whenever the nearest polar group actually determines the stereochemistry. Why? Again question, why? You are thinking that I am teaching you and I am only asking why, right? No, I am asking on behalf of you. Okay, you can't ask through this video, right? So which question actually I am thinking from your point of view, that while I was reading the what are the questions I had in my mind, that I am thinking and I am trying to explain you like that manner only. Okay, so that you don't have any queries. If you have queries also, I don't have any problem, but I want you to listen carefully and understand all the things. Okay, so now again question, why this group, the adjacent nearest polar group, is responsible for the stereochemistry? Why? Because the chelation, obviously chelation will happen from the nearest group in a better way. If it has, let's say I want cake. Okay, so Jaden want cake. Here is a cake shop, here is a cake shop. This is near, this is far. And both have same price, right? Two lone pairs both has. So Jaden will take from which group? Near, obviously. Why it will work through this O group, right? So this is the case. So that's why this from this adjacent group, see here, this stereochemistry is depending on this group, and this one is depending on this group. This is very important. Please keep that in your mind. Okay. Now one question. This is a part of question, I will say. The other part was also there, but that was not relevant to our topic. This is CSIR NET June 2012 exam. This is from, and here the A is given, and here is, if you see, two double bonds are there, and only one bond, this cyclopropane ring is formed, and this upside, from upside it is forming cyclopropane. So it was asked in the question that what is the reagent here, what reagent is responsible for this transformation. So here we are, this is allylic alcohol is present, and from the upside cyclopropane ring is formed. So zinc, copper and CH2I2 should be right. But here one other important thing is there, is that here another double bond is present. So why it is not formed the cyclopropane? Why? Because it is, so we know that in the case of carbene, carbene is the electrophilic center, and double bond which is attacking, it is acting as a nucleoside, right? It has higher electron density, but here if you see, this double bond actually goes to here. It is involving in delocalization. So the delocalization actually decreases its electron density. So it cannot attack efficiently. Okay. So that's why this double bond will attack faster rate, and also chelation is one other factor here. So both factor actually favors the cyclopropane ring formation here. Okay. Now coming to one question. The major product formed in the following reaction is, zinc, copper is given, CH2I2. Okay, you are thinking that very easy question this is. We know this reagent, right? Here double bond is present, alkene. So we know that cyclopropane ring will form. But what twist is there? What are you doing in your pen and paper? Did you draw like this one, both cyclopropane? But in this question, if you see, no option has this kind of structure, that both double bond will attack and form cyclopropane. That is not the case here. Okay, so we have to again go to the stereoselectivity. Okay, so stereoselectivity will be here. One alkene will have the better capability of donation than the other one. Okay, so let's see. So see the questions actually, which has the options we should see actually. So here this double bond is actually cyclopropane ring is formed here, and here this is double bond present here. Here what is happening? It will not be possible. Okay, so it is not possible. It can be possible. Okay, it is not possible, right? So alkene is present. How can this CO group actually attack? This can't attack because CO bond is stronger. It can't attack. And here this is the cyclopropane ring is formed from this one, this alkene. Okay, this is also possible. We know both alkene can attack, but which will be attack in a faster manner, or which attack is favorable? For that we should see the groups which are attaching with it. Okay, so here one electron withdrawing group actually present, which draws the electron density of the double bond. Okay, so it will not attack efficiently, which we talked about previously, right? So it will attack and it will form the cyclopropane ring. So the answer will be 4. Okay, next, Reimer-Tiemann reaction. So this reaction actually you have read in class 12. Okay, so if you forget, just watch it. We will I will make sure that you can remember everything. Okay, so the reaction is simply this one. When phenol is there and CH3L3NaOH is present, this will form. Okay, ortho position CHO will form. Para is also there, but it has the higher yield. Okay, So selectivity is more here. But when the only benzene CaCl3Na is reacting, then low reaction. Why? Again, why? So here electron density of this ring is more, which can actually attack the electrophilic carbene carbon. Okay. But here in the benzene, electron density is there. But carbene carbon is not so much electrophilic to draw its electron density. Okay. Without any group attaching. Okay. Now coming to the mechanism. So to know about the mechanism, so here first we are starting with, first we should know that when CaCl3 and Na is present, CaCl3 and NaOH. We have previously read in the portion where the preparation of carbene actually we have studied. What will happen? Base is present, right? So first CClCl. Cl, 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 and here negative charge will be there, and then one Cl minus will remove from here and it will form one carbene, CCl2 carbene. Okay, this carbene will form. Okay, now coming to the mechanism part. So here we know that CCl2 carbene is formed. Okay, and here phenol, this one. So phenol will attack to this. What will form? And this is a NaOH medium. So it will be stable in this manner, O minus manner. Okay. So here this one, and here it will be. Okay, this will be actually negative charge will go to this way and this will attack to this. Here no attack. Okay, just remove it. Here I am not showing the attack. I will show here. Okay. So here how? Here double bond is there. So it will attack now this carbene. Okay. So after the attack, what will happen here? Here one hydrogen is present already. One hydrogen was there. 1, 2, 3, 4 hydrogen, right? And one CCl2. It will be minus or plus? It will be minus. Okay, it will be minus. Now what will happen? So here this was, okay, not all are negative. So this negative will not be there. And here this will be this. Double bond is here. So now what will happen? Here, so as it lost the aromaticity, it will again try to have the aromaticity. Okay. So what will happen now? First, I think this one will, okay, yes. So to have the aromaticity, what will happen? This hydrogen will be like that. This hydrogen will be lost and this will be again O minus. And here this hydrogen is, see, this bond pair is going towards the ring. So it will be removed as H plus and it will accept this H plus, this group only. So what will now form? Here double bond, here double bond, here double bond, and here CH, here CHCl2, right? CHCl2 will be there. This hydrogen is accepted by this one. Now in presence of NaOH. So here, let's say here one Cl is here. Just write like that. So we know that Cl is a good leaving group. So here Cl, here Cl. Okay. Now negative charge can again delocalize and go this one and it will be removed. Okay. This will be again double bond. Okay. Now this one is this one again there and this will be double bond. H and Cl. Okay, like that way only. And now OH minus will attack here. OH minus will attack here, and again the aromaticity will be reformed. Okay, this one, and again, so HCl and OH, right? Again NaOH is present. So again the same thing will happen. This will go to there and this will go to here. This Cl will be lost, and like that way. So after the attacking and all, this will have OH, OH and one H, right? And this has the aromaticity. Okay, fine. Now in one carbon, two OH molecule cannot be present. Okay, so it will remove like H2O, and after removing the H2O, what will be there now? CHO. So this is the proof. Okay. Now the question: the major products formed in the following reaction. So for any reaction, what we have to understood is that we have to identify the reactant. So it is a phenol, substituted phenol maybe, but it is phenol. Okay. CaCl3 KOH, it will lead to the formation of CCl2 dot dot carbene, and next step is given one next step. Okay, let's not come to this one. So we know that phenol will attack and this will form. So this is a Reimer-Tiemann reaction. In first step, what will form? CHO is there in ortho position, and in the para position ET will be there. Okay. So now H2O2 and NaOH is given. H2O2 and NaOH. Okay. So H2, in presence of H2O2 and NaOH, this anion is there, OO minus. Okay. It will attack at the carbonyl center. So I will draw the carbonyl center so that you can understand it properly. This will attack the carbonyl center. This will be O negative. So OH, okay, it will be O negative and OOH, correct? And here all the things are there in the ring, right? Now there will be one rearrangement. This will go to this, and this will go to this oxygen. Okay, so it will be OH and O. This is joining with O, and it will be removed. Sorry, it will be removed, and this O has this CO. So OCO. One second. OCO will be. Here one H is there, na? Okay. 1, 2, 3. Three bonds are not possible for carbon, right? Without any charge. So here one H is there. So one H will be there. And after that, after the NaOH is present, so NaOH will attack here and it will be actually removed. Okay. So the product will be OH is obviously here. Here also O minus is there and ET is present like the reactant, right? And what is removed from here? See, CO is there and one OH. So H COOH is removed from here. Okay, fine. So what will be now the answer? Answer will be OH. Let's say it is protonated now. So from the another molecule, the OH will be abstracted from the another molecule, and this will be OH, ortho position OH, and this will be the two. Okay. This question is from CSIR NET December 2019. Okay. Now carbylamine reaction. This is also one important reaction. Okay. Which by seeing the mechanism we know that this will goes by the formation of the carbon. Okay, so what is the carbylamine reaction? It is simply when from the amine isocyanate is formed. again CHCl3KOH is present. Okay, so if you are confused, let's see just the reactant. When phenol and CHCl3KOH is present, that time the Reimer-Tiemann reaction is happening and the carbylamine reaction is totally different. So in the name itself, you can see here amine is present, right? So from the amine, if we add the CHCl3 and KOH, it will form the isocyanate. Isocyanate bond means NC bond. CN is cyanide or cyanate. This is isocyanate. Okay, and the other products are KCl and H2O. H2. Okay, so the important thing is that in the reaction is okay here. So here what is happening is that I will not show you the total mechanism. So what is happening is that NH2 has the lone pair. Okay, and here we know that carbene will form, CHCl2 carbene will form, which is electrophilic center, so it will attack here. So in let's say CCl2 minus, and here NH2 plus is present, so it will abstract one proton from here and it will be neutralized. And now in H is there and CHCl, correct? So now what can happen is that this has the lone pair, it will go to this, and as it is a good leaving group, it will be removed, minus Cl minus. After that, what will form? N H is there, double bond CH Cl. Okay, so NH will be plus as 1, 2, 3, 4. 4 bonds are there. That's why. So now, so this H will be removed. Okay, so H is removed. So that's why it will be neutralized. H is removed as H plus minus H plus, right? Now CHCl, one Cl is again here, and it has the lone pair, so it will go to this and Cl will be lost. Okay, so that's how it is forming NC bond. This is positive, and this is negative. Fine. Okay. So now important. So why this carbylamine reaction is important? Obviously for the transformations, okay, from amine to isocyanate is forming. So this is also very important, and only primary amine can take part in this reaction. So why we are saying that? Why we are saying that? Let's say it is the secondary amine. So where actually the problem will happen? Let's say Nr2 and H is there, okay, and it is attacking the CCl2. Okay, so let's say RR is there and CCl2 minus is there, and it will abstract proton from here as it will be positive and it will be neutralized now. Now R2N, this is there, and CHCl is there. Okay, fine. It will go to this and this will be removed now. So you are thinking that same thing is happening, right? But there is difference. If you see clearly that now it is this N is this R2, right? 2 and 2, 4 bond, it is positive. But one Cl is present here and no lone pair is left in the nitrogen. It is positively charged. So it can't attack. It doesn't have any lone pair in it. So this will be the product in the case of secondary amine. Okay. For the tertiary amine, tertiary amine has no hydrogen in it. So in that case, here only the reaction will be stopped. Okay. So only primary amine. This is identification of primary amine. Okay. Primary amine can undergo the carbylamine reaction. So this is used as to test the to identify the primary amine. Fine. Now, if you are asked that various amine, let's say many secondary, tertiary, or many primary amines are given, and you are asked that which amines are actually involved or can undergo the carbylamine reaction. So, you will only choose the primary amines. Okay. Now, Bamford-Stevens reaction. This is little bit a difficult reaction, and like this reaction also, the other name reaction is there. So I will talk about in other session, but here I will talk about only this Bamford-Stevens reaction. So what is happening here? Here, if this kind of hydrazone is present, okay, and in the presence of base, it will form alkene. So Bamford-Stevens reaction is from hydrazone in the presence of base, this kind of alkene will form. So in the question itself, you should have a hydrazone and basic equilibrium. Clear? So now coming to this one. This you have previously see in the preparation of carbene. Okay, in my previous lecture. Okay, so when TSNH-NH2 is present, okay, this will undergo the this is hydrogen, okay, substituted hydrogen, and this will undergo now with carbonyl, the water will be removed and this will form hydrazone, tosyl hydrazone. Tosyl hydrogen is there, tosyl hydrazone will form. Then after that, as OMe is present, it will abstract this proton and a negative will be formed here, and this group will again remove and this lone pair will be there here. Okay, this is the reactant, and now if this comes to this one and this will go to this one, what will happen? It will happen like into plus will be there. Okay, and this will be now negative. Now you can understand how this carbene is actually generated. From these to these, with heating, you know that N2 is removing and all, but how the carbene is actually forming, you should see this intermediate. So here, after heating, N2 will be removed. N2 will be removed how? This way. Okay, it has the negative charge, and this one group will be removed, so that it can form the carbene. Two bond it has and one lone pair. It will form the carbene. Okay, so this is still the carbene formation we have drawn. Okay, so carbene is formed. Now what? Now what will happen? That is the question. Okay, so after the carbene formation, if this is the carbene formation, okay, here carbene is formed. Now what will happen? In the reaction medium, nothing is there. NaOMe is there, which is acting as a base. Okay, so what will happen now? We know that one of the most important reaction of the carbene is that the insertion of H. Okay, so here H is present in the adjacent carbon. It is present, right? So it can go to this one. So how we can write? This is radical, so it will be here. Sorry, just like that way. So here I will show just the breaking of the H. I previously also have shown to you this one for only the understanding purpose. This is nothing like this kind of reaction is undergoing this kind of radical formation and then double bond is formed, nothing like that. For the understanding purpose only, this will be here and these two will be together to attach the hydrogen. So now the product will be pH it has hydrogen and double bond will be there, and so this will be the product. So alkene will be formed. R1, R2, R3. So how it is there? R1, R2, R3. So in the case of hydrogen, if you see, so it will be R3, let's say R3, and this, okay, this is R3, and this is, okay, okay, one hydrogen will be R2, let's say 2, this is R1, okay, R1. So here is also the same thing, R1, R2 is there, and in the alkene, one carbon has R1, R2 and other has R3. So one has R3, okay, and another one has R1, this is 1, and R2 is hydrogen. Okay, same thing. Now, use of approaching solvent is must here. Again, question, why? My favorite one is the question, why? So, to understand it, again we should go to the mechanism, obviously, to explain anything inside the mechanism. So, if protein solvent is here, what will happen? I have shown to you the intermediate, right? So, from here, if I draw, this will be pushed to this and this will be the negative. So if I draw here, this will be N2 plus and negative, right? This will be one of the intermediate, and then this N2 will be removed and carbene will be formed. But if protic solvent is present, what will happen is that pH, here one H will be there and N2. Okay. So after the heating also, here how actually one condition, so see the reactant is also same, the condition is same, only condition is different. Where only protic solvent is used. So how it is affecting in the product formation, let's see. Heating is there, heating, okay, so N2 will be removed, minus N2 will be removed means it will go to this one, but it is previously abstracted one proton. So after the removal of nitrogen, what intermediate will form? Positive. Carbocation intermediate will form, not carbene. Okay. So that is the thing here. So this carbene, carbocation is there, and OMe is also present if a medium. So it can attack here. So then the product will be different, obviously. And also the alkene is also possible here from here. Okay. So various actually things are possible. Alkene is also possible. Some nucleophile if present, it can also attack. The protic solvent can attack. Okay. But here in the case of this, what will happen? Carbene will form and it will abstract the proton. Okay. From more hindered side. It is thermodynamically controlled. Thermodynamically. So in the case of thermodynamically controlled, what will happen? What will happen? In the case of thermodynamically control, it will happen on, it will not, we will not say that which reaction has low activation energy or how much energy is needed. Not like that, only the stable product we should know. Okay. The reactions which are thermodynamically controlled, that will undergo the most stable product formation. Like two products are possible to form, okay, but the more stable one will be in major amount. That reaction will be called thermodynamical. And now we have the question that, so what is the reaction where the minor product will be, sorry, the more stable product will be the not the stable one. We know, right? Stability is the driving force. So we will say that it is must for a reaction. The stability of the product we want, right? So it will be always thermodynamically controlled, but not like that. So if we see the energy profile diagram here, it is, let's say, reactant and this is product R and P. Okay, so P1 and P2, let's say it is possible. So in the case of thermodynamically controlled product, the P2 is in higher amount. P2 will be more. Okay, but when P1 is possible, we know that stability we want, right? But another important thing is there is that the activation energy, of course, here is this, and other one will have high activation energy. Okay, so where the activation energy less, that reaction will be in faster amount. Let's say it needs 60 kilojoule heat. Okay, the activation energy, let's say, and it needs 40. So if you are giving 50, it will not undergo this kind of product, but it will undergo very fast. Reaction will be there, and P1 will be formed naturally. So that kind of reactions are called kinetically controlled. P1 will be then measured where? In the case of kinetically controlled. And this is thermo. Okay. So while you are reading the many reactions or the heterocyclic chemistry, everywhere this concept will be must. You have to have the concept of thermodynamically controlled and kinetically controlled product. Okay, so sometimes the product stability will be majorly we want, depending, it will depend on the reaction medium and the conditions. Okay, so both are actually possible. Clear? It will be kinetically controlled product will be in faster rate if we has, let's say, less amount of energy is given, but thermodynamically controlled product is it will undergo slowly, but when it will form, then it will remain as it is because the stability of the product is more, right? So where were we? Why we are reading this one and this one? So here I say that in the case of Bamford-Stevens B reaction or BS reaction, the thermodynamically controlled product will be formed. Product is alkene. Thermodynamically controlled alkene means the alkene should be more substituted. So simple thing what we should remember, more substituted alkene will form majority. Okay, so I wanted to say this one, but if you know, I don't know that you know thermodynamically controlled, kinetically controlled. So to for you actually I have explained this. Okay, in a little bit, just I wanted to give a idea, but I have to, this will be needed in future obviously to understand the organic chemistry reactions and the product formation. You must have the idea. Okay, so again I will explain you, but if you try to remember this one. Okay, these concepts are actually needed. So that is the thing. In the case of Bamford-Stevens reaction, what will happen? Hydrogen is there and basic medium is there. So it will form carbene and N2 will be removed and more substituted. Alkene will form after H insertion reaction. Okay. So now again the previous year question. This is from GATE. Okay. So this is actually, if you see, CH3 is there and double bond NH. Yes, NH SO2 Ar. This is CH3 and double bond NH SO2 Ar. This is top side. Yes. Okay, that can be removable, you know. So NaOMe is given, NaOMe and heat. It is needed for into removal, okay, and thermodynamically product formation also it is needed. So because for the high activation energy, so we know that here carbene will form, okay, carbene will form obviously here. Now what will be the product? So because here also H is present, here also 2H is present. So you will say here more because we have a we want food and here more food is there. But so what is the important thing here? Important thing is the condition. Let's say some condition is given that you want you want non-spicy food, but here spicy food is there, right? Like that way you can understand it. So these hydrogen will be the insertion will be this hydrogen will happen to this carbon and the double bond will be here majorly formed. Here hydrogen is there, so this will be the product. C will be the major product. Understood? And this is the minor product, which will be not the product. So here what concept is needed? Thermodynamically controlled product. Okay. So see, you understood the topic. Okay, you understood the topic, why it is needed, what the things are needed, everything you have understood, and also you have understood or you have seen the applications also, like the questions, how the questions are actually coming. Here you can see note B Bamford Stephen, sorry, BS reaction or nothing is given here, right? Only reaction and the conditions are given. So you have to have the idea that what kind of reaction it will undergo. Okay, clear? So now that's all, and thank you so much for listening. So please read these two chapters, lectures of carbene, so that you have the idea of various name reaction as well as the carbene, because carbene is very important for any kind of a competitive exam. So I hope you have enjoyed this session. Thank you.